Okay, now we're over on the Windows side. I'm running git bash. Um, I have a shared folder between my Linux VM and Windows, and I copied this SERV RISC file over from there. I'm going to make a folder, mkdir /c slash, I'm going to call it SERV ICE. SERV ICE. So because this will have the SERV SERV RISC processor and the Icicle. And so I'm going to make that folder. And then I'm going to move this file to this directory. And so just to see what I'm doing is that as I go and I double click, double left click, middle scroll bar, click. That's my cut and paste. And that's that. So now that we cd /c slash service, and let's do tar zxvf. Z uncompresses, X means extract, verify, and F for something else. Who knows? And then hit return. And so this is there. And let's clear the screen so it's not so ugly. That's okay. And if we do a find dot rip dot v $sign tick. So what this is going to do is going to find every file in this directory and all subdirectories. It's going to then search for the .v at the end. The $sign means it's got to be at the end of the string. So it should find all the files that end with all the Verilog files. Whoa, a lot of them, huh? All right, so we've got this. A lot of them. A lot of them, a lot of them, a lot of them. And I'm thinking that I don't know really what the difference is between here and here. They're probably the same. But I'm thinking build is what we simulated. So build is what I'm going to build with. So we've got these. What are these guys? Trying to figure out. I kind of really like this RTL files. That kind of makes a lot of sense to me. Servant. Then we got all these SERV files down here. I think that's what I'm going to go with. What are these things? So these are here bench servant GPIO.v. So what do you think? Do you think we need these files as well? That's tricksy. It's tricksy. Because we have a timer up here. Servant. Verilog TV sources server. Actually, we got Verilogs. So it looks like the Servant ones, these files are the same as these files. So I'm thinking what we need in reality are these files in order to do, got an aligner here and an aligner here, and an ALU and an ALU. So I think that what I really want is everything in the Servant. Servant is the serve plus like some memories, some GPIOs, some timers, I don't know, some other useful stuff. Not an expert yet. Probably what I don't need is this servant underscore sim. So, okay. Don't want to waste too much time here, but those are the files that we're going to end up including into our Libero. So let's get this just kind of put this up for me. And LS, slightly different path. I gave the servant one and serve top. Why did I get this one? Okay. Now we need to install the or clone from GitHub the Icicle reference model. So I've got the path right here. Boom. Right here, it's in the Polarfire SOC on GitHub. Click on the code, left click, left, few clicks here, Control C, go back to here, and let's see, git clone, middle, and hit enter. All right. So now we're ready to start Libero. And what's the file of interest is let's see, do an ls icicle. Oops, ls icicle. This file here is the tickle script that will build the entire design. Then once the entire design is built, then we'll add the serve to that built design. So we've got this. So now we're going to fire up Libero and give it a shot. Here we go. So down to here, LIBR. Libero, sorry, Libero. And here we need 2023.1. So different reference kits to use different libraries and different other stuff. So Icicle wants, I use for Icicle V2023.1. I'm going to switch over to the Beagle V Fire. That'll want 2023.2. So let's start this guy up. If you like, and now fine. Okay, let's create a new. Don't do that. So we're going to click on project. And we're going to go down. Oh, first thing before you do the script, you want to make sure your vaults and repos are set up nicely. So click on that. Let's see, cancel project, vaults and repos, left click. Make sure that you have all of these here with all these Microchip IP. You should have 3 of them, direct core, firmware, and SG core. If you don't, such as like say you're missing these or something, then click on the defaults button and that should put them there. And so that gets you the external repositories with all the IP that you'll be needing. And you want to set up a vault location. And I have it set up here. I'm going to change it to, so I want to put it in my SERV RISC area. So you saw how I did that, right? Let's do it again. Okay, so here I double left click. Let's see. No, I was here. I clicked on the triple dot, left click. I left clicked on the OSC, And I scroll down, I look for serve ice. I left clicked on it. I double left clicked on it. Now I'm here and I want the vault right here. So I right click, new, slide over folder, left click, call it vault. Left click, I guess. All right, click on the vault with a left click. See that it's down in the folder. Select folder. And so now we have the vault selected. We have the repository set. We say OK. We say OK. Once thinking. It takes a little while to think. You'll have to say OK once. Now here, successfully updated the vault. Nice. Left click on OK. Now you can go back to the project, left click, scroll down through, execute script, click on the triple dots. We don't want this ice one, which is a previous project. Here, go down to double left click on serve ice, double left click on Icicle Kit, double left click on MPFS, and that starts it running. Here it is. Any arguments? No. Click on left click on run, and now it goes. And this will run to an end. It'll take probably, I don't know, a few minutes. I won't talk anymore. So basically, this will run to an end, and then I'll have the next section start up where we're doing, I guess, merging SERV into this reference design. So you can see it's doing some pretty cool stuff here, and it's building. All right, let's close this script. Oh, I always like to save it, don't I? I don't know why. I think someday maybe I'll be smart enough to understand what it says. Uh, let's save it here. Boom, let's save. All right, nice. Okay, now we can close it. Now we have this beautiful design, and we're ready, I think, to start pulling in the serve design. So what we need to do is we need to go to projects. Let's see, the project, no, file, import, HDL source folders. And where would we go to? Click on this little up arrow, left, up, to see. Let's see, scroll down to serve ice. The stuff was put into this server. This workspace. Build, I think I decided that we wanted to build. I think everything we wanted was actually in the Savant. Into here. And let's see here. Source. All right, so here we got two source files. I wonder if we can just click on this one from this level. I'm not sure. I'm not sure. Let's dive in. Uh, I think this folder RTL has it. Let's choose. I think that pulls in that one. And now we want to do a file. Left click, import, slide over, slide down to HDL source folders, left click. We're here. Let's go up one level. Now we want to do the Servant. And Servant. Is that what they really called it? Oh, yeah. So let's go up arrow again. All right, click on this Servant. That's that. It's in the directory Servant. Left click on choose. And all right, I think we've just chosen a bunch of Verilog files. And now we scroll up and down and we click on the Design Hierarchy tab right here. All these tabs is kind of tricksy. A lot of tabs down here. Design Hierarchy, User HDL files. And you see it. Look at all these SERV files that we've added. That's probably kind of cool. And now what we want to do is we want to click on the left click on the Build Hierarchy. And so that's going to actually parse through all of these files, figure it out who's on top, who's on, so it'll figure out the whole hierarchy. It's kind of nice. Yeah. And it came in, and after all its work, it said that survival is the highest hierarchy, which is kind of nice. And now, so what we're going to do is we'll left click on it. I don't know if you need to do that, but I'll right click, say create core from HDL. See that? Let's do that again. Right click on Servant, slide down to create core and left click. See, signals and parameters were automatically extracted. That's nice. Would you like to remove any of the parameters? Let's say no. Left click. And I think that's done. And now, this is a core. That's what you can do with a core. This is what they call a smart design. It's basically a schematic. We want this guy, one of its outputs, to be connected to, let's scroll over here. If you're in this smart design window, you can control scroll. Actually, I've noticed that this is a pretty common interface with graphics tools. Control scroll allows you to scroll in and out. Just scrolling without touching anything allows you to scroll up and down. And if you press the shift, it allows you to scroll left and right. And that's a pretty standard interface. So right now, control scrolling in. And what I'm looking for is those LEDs. Look at those little rotten LEDs. There they are, 4 of them. All right. So now what we want to do is take this guy, drag him over to here. Have a little muting him, will ya? Isn't that cool? This is Servant. Not much to it. All we've got is a clock reset. Built into it is the memory. And yeah, what else is there? And then the cube, which is going to be the output, which goes to the LEDs, which is nice. So what we're going to do is we're going to light up. Let's see. Well, where's 2? Where's LED 2? That little rascal. There it is. So we are going to light up the first 2, 0 and 1. What we're going to do is we're going to click on the name, left click on the LED 0, and then right click, and then disconnect. Then we're going to collect, and then we're going to go down to this queue here. We're going to left click and hold. Then we're going to move the cursor, moving the mouse, still holding with left button to here. You get the plus sign, and then you can let go. And that's just connected it to the first blinky. And now let's just for fun, right click on LED 1, disconnect him, and let's connect from here, go to this wire, Left click, hold, drag it over. Well, so the first two LEDs on the Icicle should start bouncing. They're connected to this Q output. So we should see two LEDs doing the identical thing. And that would be a good indicator that we're doing something. And now we got this reset and, reset, reset, reset. Ooh, okay. I think that's a reset. That's a high active reset, isn't it? All right, first of all, let's try to get ourselves a nice clock. So here's a clock, P clock. I like that. I think it's like 150 megahertz. I don't know how fast the RISC processor can actually run. This is 150 megahertz. Might have to slow this down. I don't know, but for now, let's go for it. So drag it over. All right, we're at the clock. Oh, let go of the left click, left button, and connects it. Then we got this reset, but it's a high active reset. Usually everything here in this design is it's like a low active reset. Um, See this P reset N? That N means it's a low active reset. So what we want to do is we pop down a logic gate in front of it. Let's see if we can figure that out. Let's go to the catalog. Let's go to this search box here and type in INV. Look at this. We got an INV, which is probably an inverter. So left click on it, drag it over, put it down, and there it is. That's nice. And now what we want to do is we want to connect the output of this inverter to the input of the reset. And we want to connect this side here. We know where we're going here, so let's scroll out a second. And let's left click on this, see this P reset. So let's left click on him. Hold, click and hold. Click and hold. Let's go to our inverter that we just added. Go to there, you see the plus sign, let go. All right, and now we've got those two sides connected. I'm hoping it synthesizes okay. This has the block RAM inside of it. So I think we are kind of good to go. All right, one last, let's see, that'll happen much later. And much later in the build process, we will associate a hex file with the memory in here that actually has the program that will run the servant, the serve. Okay, I think this is it. So I think let's see. So let's go and go to this little yellow can with a gear on it and do a left click. And so you can see it says generate component. So that'll generate, it's basically compiling it again. It's looking for any errors that it's can find. And maybe it had some warnings, but I think for the most part, it came out not so bad. All right, now all we have to do is, again, we have these tabs on the catalog one here. I don't know what the heck you do with components yet on files. Never really used him too much. I've never really used the stimulus hierarchy too much. I use this design hierarchy. That's where one of the things is you might have remembered that there was a servant up in this area because it's basically showing the top blocks. Now that that servant is pulled into here, it's no longer a top block. So it's no longer being shown. Now, let's click on build hierarchy, just for good measure. And then when that's done, we will click over on this design flow tab, which is when we're going to go in and synthesize, place and route, and generate a bit file. Do we want to go that far? I don't know if we want to go that far. So I think that's done. So here we just clicked on that. Because somewhere around one of these steps, right here, I believe, configure design initialization, we will want to associate the hex file with the SERV's memory, its block RAM. So let's double click right here on the configure. Let's double click on generate FPGA array. Okay, so it's going to run. It's going to run for a while. Play some music, go away, come back in probably 25 minutes. All right. Looks like it's done. So next step, let's see if we can configure the memories. All right, so two steps. Well, first of all, let's double click and configure the memories. Fabric RAMs. Click on that. Not sure what to do. We got the CPU with RF RAM. That's the register files. We got Servant, a RAM, memory 1, memory 2, memory 3. Now this could be a deal breaker here. All right, so we've got a hex file. Let's see, hopefully maybe it fits into. We got 3 of them. Why isn't it mem0? Sure, I don't know. So let's first find, let's go back to our git bash window here for a second. We're in service, we're going to do an ls. Um, and we're going to find everything in this serve directory and subdirectories. And we're going to look for hex. We're going to grep for hex. And then we're going to, this is the blinky that we want. Not really sure of what we should be doing here, but just remember this path. So workspace, fuse, SOC libraries, serve, software, blinky.hex. All right, let's go on, let's try it. Maybe it's a simple hex. Let's give each one a try. Just trying stuff now. Alright, so let's cancel this. Close this. What do we want here? So let's go back to here, here. Let's code it. We're going this folder here. So we so this is fun. Oh, that's nice. Huh. That is Blinky. That's pretty cool. Alright, I'm starting to get a notion that we've got 4 of these guys. 1, 2, 3, 4, which I believe makes the 32 bytes. Um, so somehow I think that we have to split that hex file into bytes so they can map into here. Yeah. Why would we do this? Why would we have 4 memories? So we go to here, go to here, and Intel is forward. Over here, kind of want it to look like a colon and a bunch of stuff. You know, so we not an Intel HEX form. That's clear. Let's see, does Wikipedia give you other variants or? So there's something with an S file there. Oops. This guy here. Control Q. Oh. Typo. Fix the deadline. So we've got a S file. Maybe like the S file. LED blinker. Assume the GPIO base is mapped to GPIO. If def. All the stuff here. This is the assembly language program for blinking. That's kind of cool. All right, I'm gonna have to cheat. I don't want to cheat. I'm gonna have to cheat. I don't want to cheat. Yeah. This has been pretty much of a disaster. We're going to have to, we're kind of close and not close at all. So let's shut down and reflect on what we want to do with our life. Okay, shift, print screen. Goodbye. So we must start with a colon. So we must not have an Intel HEX file. So let's try double click, contents from file.